Hello everybody, Randy Richard in the shop. This is where we left off on our Fusion engine with the cylinder, of course, operating and the piston operating. Now we're ready for the crankshaft assembly, and we're going to make that as a sub-assembly like we did the piston. Just so we have a little more practice at sub-assembly type thing that is not in the same drawing or the same model. So we'll create a new drawing or a new model. Click New Design at the top. Let's save it right off the bat. Crank shaft sub assembly. How's that sound? And then we'll create some components after my computer catches up. There we go. Then we right click on there and say new component. First component will be the crankshaft. And we're going to create all the components at once here. I mean, at least their headers all at once. Crankshaft, then we'll do the flywheel. Then we'll have the crank web. And one more, we'll have the crank pin. We'll make crankshaft our active component. And of course, S for sketch, create sketch. Okay. Now this sketch I'm not going to do a profile on. It's very simple. It's just a 1/4 inch rod with a flat and a straight knurl on one end. And so I want the Z axis here to be my axis down the center of the crankshaft. So I'm going to click on this, the XY plane. We're going to C for circle, right in the middle, 0.25. Stop sketch. A Q for press pull, let's say, and we'll do that, and it's 2.5 inches long. That's our crankshaft. Now we need a flat on this far end, and we want to show a chamfer on here. So what we're going to do is we're going to chamfer it first. And this is going to give you a little bit more insight into project by doing this, if we do this first. And I don't know, 20 thousandths. Yeah, that's a nice little chamfer, 20 thousandths, see? So on both ends are chamfered. We'll go to the far end down here on the right. We'll just create sketch, and we'll select the very end. Now, I just want to create a flat that's cut away from the top of the shaft for a 1/2 inch deep. And if I do a line and just draw it across here, now my plane is the small diameter, not the large diameter. So I can see how it snaps to the diameter of the small part of it, which is kind of nice, and I could just snap there and draw a line across, right? I'm going to delete that. But really what I want is a line across the large diameter. But if I do line, I can't snap to it because it's not on the same plane. So this is where project comes in handy. So if you do P for project, select that outer diameter and say, okay. Now I'm going to turn the work, and you'll see what it did. What it did is it projected that circle showing the outer diameter onto the plane that we're working on right there. See that circle? And basically that's what project is. Project is projecting something to your work plane or your to to the plane you want to work on. It projects the profile of something onto that workspace so you can use it. Now when I do line, I can snap to it. See how it snaps to it now? And I can just go straight across and snap to the other side and say escape. And I'll set a dimension from it, the center up here, 0.1. Gives us plenty of room for a flat. And now it turned green, and with the blue background, green means it's constrained. We'll do a line up, over, and then down. There. And we'll set a distance. We'll put a distance on that so we can fully constrain it. We don't care what it is. And now we have a nice little box that we'll use for cutting. Stop sketch. And we'll press pull that again, and we'll select all three of those little bits, and we'll just go down here at 0.5. Oops. Edit feature, minus 0.5. Oops. What else did I do wrong? I had join and then you cut. There. Gotta make sure I click all the boxes. And now we have a nice cutaway where the flat goes. But that I just wanted to do it that way to show you the project feature. The other end has a straight knurl. Now, knurling is not a feature within Fusion. If you want it to be an actual feature where you might actually machine it with CAM, you'll have to actually model it. If you want it just for looks, it uses up a lot of calculation and uses a lot of resources for your computer. But this is a very small piece and small knurl, and it's within this one model. So I'm going to draw a straight knurl for you, and it won't eat up too much resources on us. And it won't take very long to do. So we'll do sketch again, create sketch. We'll use the end of this plane. And we'll do the project again. Project. We're going to project that outer diameter. Say OK. And we're going to zoom right in here. We're going to sketch the form with a polygon of our knurl. Now a knurl is just going to be a V groove in all essence, right? So you kind of snap on that line if you want. Polygon, make it 3, and then we're going to make this point 0, 0. Let's make it 4. So 2 thousandths, I should say. 0.002. See, and that's a radius of the inscribed circle. So this is about four. Well, it should be about 4 thousandths across. Since this is just for a aesthetics thing, reminding you need to knurl this, that'll be fine. And then we'll take the horizontal vertical constraint and click on that. And what it did is made that horizontal vertical, moved it. But if we grab this now, it will stay locked on the outer diameter. And we should be able to drag that over and roughly snap it in right there. It's fine. We'll use the coincident. It's already constrained. Let's see what else. To get that to be constrained fully, probably have to put a line in. Make it a construction line, and say that is coincident with that, and that will fully constrain our drawing. Stop sketch. We'll do a press pull. Select little triangle, and it goes in for 0.2, minus 0.2, minus 0.2. Okay, it's a cut, and you have this little V groove. Okay. Now we'll do under create, we'll do a pattern, a circular pattern. We're going to select faces, and we're going to select all three of these little faces in here. Okay. Axis, we know is the Z axis, so we can go over here and just say Z and say 3. No, try 100. See how long it took to calculate that? Now you can zoom right in here. You can see how it has a little bit of a flat on it. Now if you wanted to edit that feature, you can go down and click on it in your history line and say edit. And let's make it 120. It all matters how much of what kind of form you want. If you want it to be real sharp or a little bit flat. I'll leave it a little bit flat, but that's how you could edit it. Now we have a nice little straight knurl. Now making a diamond point knurl is very similar, but it's a little bit more complicated, and you're going to use a coil and all that. I'd have to make a separate video on how to show you how to model that. All right, crankshaft's done. Let's go to Flywheel, make it active component, and we're going to do the profile method of making the flywheel, and it will take us I think it's 3 sketches to make the flywheel. And I did draw this in a couple other methods, and I still end up with the fastest method is 3 sketches, no matter what I did. So the profile is probably really the easiest. So we'll do sketch, create sketch, and we'll sketch it on the Z-axis. So we select that plane. And we'll draw a center line for our length, and that's 1 inch. So we have a referencing line, and let's see here. The hub is offset mostly to the end here, so it's 0.7 divided by 2. Line. It comes in. Now we're just going to sketch kind of roughly what the flywheel looks like. There, goes up, it comes over, it goes up, goes over to here, and down, in, down, over, and down. So there's our rough shape of the flywheel, and there's a bore, and so we have a line in here like that. Well, our bore diameter is a 1/4 inch. We know that 0.125. Then half of that. The web width. Let's make this a 1/4 inch. That's plenty thick enough web. Let's see here. This dimension is 0.625. And what we want, though, is we want the center of that line to be on the center of this, and this to be collinear with that. So let's use some of our constraints here, collinear, and say this one needs to be collinear with that. And since these are all building as constrained parts, so that's good. So that's constrained and that's constrained. And now we want this to be in the middle of that. So let's put a line at the midpoint. Just do that, make a construction line, and then we're going to say this is symmetrical about that line. Oops. Back up here. Do that again. This one, and then Always select your 2 lines first and then the one you want it to be symmetrical about. Let's see here. These lines we want to be collinear. This one I want to be collinear with that. And we need some dimensions. So the overall outside diameter, oops, it is 2.187 divided by 2. And this here works out pretty nice looking flywheel at 1.5 divided by 2. There you go. And it's fully constrained, it looks like. Yep. And we could say stop sketch. We'll do a revolve of only that portion. Okay. Select the axis right there. New body, say OK. And we have our flywheel. Now our flywheel has a set screw on the top here. So we'll put that hole in now. And the easiest method I've found is using a tangent plane. And it's going to make it plane tangent to the face. So select the face you want it on. There it is. And see how it's nice and just rolls around the face. Then you want to select a reference plane. And we'll turn on the origin for the flywheel so we can see it real well. And not that one, this one right here. Now either one of those would have worked, but this one, it will be 0 degrees and it will be on top and parallel with our little flat. Then you go back to sketch and create sketch and select that new plane you drew. Now for this one, we're going to do this a little different. We're going to put a point in. And we're going to do right on the axis, just snap somewhere on the axis, and that looks like a good spot. No particular dimension, just whatever is okay with you. So let's say make it 0.160. That looks pretty good. It's about halfway. It really incidental. We know it's going to be on the shaft, and it should work out. Stop sketch. Now I'm going to do a hole command, and I'm going to select the point. Now that hole's a little on the big side. Let's this is a 1032, and it's going to be a threaded hole, flat, and we'll go down here. Let's select the number 1032. So we know, see, we can get a relative size. Now, if you wanted to move it in or out, you could easily do that. And then over here, we don't want to cut too far. We don't want to cut into the shaft. So we're going to look at this, what we're doing. And we can just drag this up there to match where the flat is. Pretty much. And get your box up and say, OK. Now you have a threaded hole, 1032, already in there. And we can put a set screw. We'll do the insert command, insert. Oops, back up here. Set screws, there we go. 1032. Cut point, fine. 1/4 inch length is what we want. Let's see here. There we go. Product detail. Everybody should know how to do this by now. Step file. Save. I'm just going to orient it a little bit better. There we go. I'll do a point to point, and we'll select something that's going to give us the center. This is a little bit difficult because you're going to get radiuses and stuff. There, control, hold down control, select the center one right there, target. Now since we did not model that hole, the center is a much easier thing to pick up, and say okay. I'm going to do all my joints at the end and lock everything together at the end. Flywheel's done. Let's go to crank web. Crank web sits right here on the end. So we'll just go sketch, create sketch. Oh. Create sketch. Select the end here. Capture position on those other ones. C for circle, 1/4 inch, right, for the bore. C for circle, and it's 1.125. 1375. And there's a C for circle for the crank pin. And we just go down the center line, and that is 0.187. And we need to dimension that. Now, the dimension here is something to remember because this is 0.562, but that's the dimension that sets the stroke of the piston. So if you felt compelled to have to change that, this is the dimension you might want to change that stroke length. Let's see here. So we're still not constrained, are we? So if you put a line in, construction line, and just say that this is a coincidence to the line, it will constrain that. That keeps it on center line, right? Stop sketch, press pull, select just the disc you want. Those others are holes. New body, and it's going to be a minus 0.25. Now what happens here is this is just pressed onto that knurl. There's no set screw in this. We're done with that. Crank pin. I'm going to draw it from over here on the back side. So I'm sketch. I lost my little icon. There we go. Put it back. Create sketch. And select the back side of that. I'm going to say C for circle, 0.1875. It's actually it's going to be a 3/16 rod. Stop sketch, press pull, select that, and it's 0.75 in length. Whoops. I keep doing that, huh? Edit feature, minus. Okay. Now you want to, on this one, this is the same basically as the crankshaft, and you'd want to chamfer each end of this. To make it easier to slip your con rod on and to press it in here. Now this also has a straight knurl on it. We can just hide some of that stuff. Sketch, create sketch on this end. P for project. Select that outer one. Okay. Align. Or no. A polygon. Let's get that right. And we'll just come up here like we did before. Straighten it out. Put a line in. And just drag it over here. I lost it. There. Do this again. That's it. We're going to make this 1.001. I didn't put that in initially. Press pull, same. Cut. Minus 0.2. Okay. Okay. Create pattern, circular pattern. Axis. We do just select, there's no axis, but select the outer surface of the pin and that acts as an axis. I think 120 is probably pretty close, good enough for us here. And that looks pretty good. You can then turn on all your other objects and select the base object, and we have a crankshaft assembly. Now we're going to go through as-built joint. We'll do this one to that. As-built joint, this to that. As-built joint, the screw to the flywheel. And an as-built joint, flywheel to shaft. There. Now we're all rigid and all hooked together. I think we're going to be fine there. And if you wanted to, you could ground the crankshaft here. And we turn off our origin, we turn off our joints, making sure our origin and joints are all turned off. If you don't turn those off, those will show up in when you move this or have it appear with your main model. Those joints will be there, and then you have to come back and turn them off. If you do all this ahead of time before you make it over to your model. So if you're going to do any appearance stuff, we could say A for appearance. And we just did some, where was it? We did our paint. Glossy paint. We used blue. And we used, what did we use? Red. Our color schemes. So let's make the whole flywheel blue, and we'll make that blue, and we'll choose faces, and we'll make that face red, and make that face red. And the other ones are already steel. Those are my default. And we'll put our decal on this face right there. I just have to, there we go. Turn over here and give it a little positioning, a little better positioning. Yeah, somewhere in there. If you zoom in, you'll have a little finer detail in that movement. Say okay. All right. Now we didn't do any saves along the way, so we're just going to save, and we'll just say final on that. And we're good. And we'll give that a few seconds here to save. Now I have a bunch of versions going because I've drawn this several times to get this or what do we figure? Well, okay, so that's a basic flywheel. One thing we forgot here, we'll go back here to flywheel, and we did not put any spokes in our in the web part of the flywheel. So we can do that. We'll just say sketch, create sketch here. I selected the flywheel as the active object. Select the center. And I'm going to put a line up here, construction line. I'm going to do another line. Let's say right. It doesn't really, anywhere in here, just a vertical line. We're going to make that, we'll dimension that line, and it'll make it 0.125. C for circle, we're going to put some 1/4 inch radiuses in, 0.25. C for circle, and just drawing those anywhere. Then we'll use our constraints, tangent constraint, tangent to this line, that circle, this circle tangent to this circle. This one tangent to the line, well, we could say to the circle, and then tangent to the line. And if you trim off some of this, let's see, trim that, we'll trim that, trim that, trim that, trim that, and trim that. Now we have a 3-segment line here. Say escape, and we can then sketch mirror that, those 3 segments, and we'll select our mirror line as our construction line. Now we have the same over here. Okay, that looks pretty good. Now you can do this part 2 ways. You can circular pattern those lines all the way around, or you could make this a cutout and then, make this a spoke and then make a circular pattern for the object. So we'll just do the circular pattern right now. Circular pattern, and we're going to select all 6 lines like that. Select the center point, of course, there, and we have 3. Let's make it 5. Say OK. So we'll have 5 spokes. And we'll stop sketch. Then we'll do a press pull, and we're going to select all 5 of those. All right. And come around over here to object to this other side. Say cut. OK. There. Now we cut in our 5 spokes. Now it's done, right? So now when we save it, we could say added spokes. And then we saved it. Oh, we should go back to our final assembly, I guess. We'll say save again. Now back over to the Fusion engine itself, our base drawing, and we will find your crankshaft right there. This is mine, and we'll just drag it in. And there's the crankshaft. We can rotate it around how it ought to be, probably. It's just a spatial orientation thing. If you don't have to do this sort of thing, but we can just to get an idea of what we're doing. There we go. We can do a point to point, and I am going to select. Don't select the shaft. All right, your first instinct might be to select that shaft, but if you do, you're going to end up with some point in between here, and it just makes it more difficult. If you select this face of the crank web here, and it gives you the center, hold down Control, make sure you get that point. It gives you some referencing. And we're going to select the face of the main of the base itself, not the bushing. And we'll say Control, and there you go. Now it's in, and we know that this face is against that face. We can say OK. And Now your piston, you can rotate your piston. You can see where the piston rod's going to sit on your crank pin. Obviously this crankshaft needs to come over, needs to come to the outboard side here a little bit so we can get our piston rod more in the middle of there. So what we'll do is we won't do a move, we'll just create our joint now. Let's say capture position. And we're going to select the same face and select the center again. Then we're going to select this face and select the center again. Of course, that's in the middle, right there, right? And it's going to be a Revolute joint. There we go, it turns, and we're good. But what we need to do is change our Z offset. Now, if you go back here, you can just grab this arrow and just drag it out, right? And let's see, that's probably close. It's not dragging everything, but we'll say okay and take a look at it and say, oh, that's not too bad. Go back if you want to do it some more. Edit joint. That was a tenth. Let's say another 50 thousandths. Let's say okay. Oh, that looks pretty good. See now how it lines up in the middle a little better? And it turns, just like we're supposed to, right? And I can't move it, okay? So that means it's locked in, and all the other parts are locked in. All right, now here's the moment of truth, right? How do you connect the crankshaft to the piston rod, and so the piston is going to go in and out, the cylinder is going to go up and down. How does that all happen? Well, you'll want to put a Revolute joint on there and this between the bearing of the piston rod and the crank pin, but usually that does not work. Yes, the action is a revolution action, but the computer, I don't know, sees it and it doesn't align necessarily right with the joint because you'll have to pick the end, the middle, or the other end, and it's very difficult to try to get this to align axially. So what I do is I'll use a joint, I'll capture position, and I'll use a cylinder joint, and that gives us axial motion and revolute motion, and it will align properly. So we use the cylindrical joint. We'll select either the face or the bearing and get the center, and just select the end of the pin, the crank pin. And that's going to go right on there, and it's going to fit, right? Say okay. Now you had no problems putting that joint in and no errors, and if you grab your flywheel, that should just turn just fine. If I can get it all to turn, right? There we go. You have a working engine. Now, if your engine doesn't work, make sure your limits on your joint, the cylinder to base joint, the limits are not too small. Ours are 13 degrees plus and minus, and it's enough. That gives us enough. Remember that that is a maximum minimum angle that we set. It's enough for this to operate, so it's within the 13 degrees. Okay, and that's fine. It's just enough to allow it to operate. Then you can look at the end here, and this is your maximum stroke right there, and this is we come around here, get it to turn, this is our minimum stroke. So you're at your minimum stroke. Does your head of your piston rod hit your gland nut? And there's enough room here to adjust the gland nut. We have a little gap, and it's enough here to so we can adjust that and not have the piston hit. So our stroke looks real good. You can then take your cylinder, select your cylinder, change the opacity down to 30% or so. And you can watch, you can look inside now, click out, and you can see your ports down in here. That port is on the base, and on the base, those upper ones, and this angled one is your cylinder port. And as you move it, you can see how your alignment on your ports look. That looks real good, huh? We're not overshooting them. It looks really good, alignment-wise, on both of them. You can also check your ports. You can turn it here, and you can check your ports on your piston, making sure you're not. Let's see here. I got to grab everything to make it move, but right there is the maximum at this end, and our port is fully uncovered, plenty of room, not going to hit the head or anything like that. And on this end, we have plenty of room, a lot closer, but we still have plenty of room for the cylinder not to hit the end. Now, the only problem I have with this right here is where is the port? Okay, right here. Let's look down on it. As this piston comes all the way up, and that's just right there, it doesn't have the O-ring go over that port. It just touches a little bit, so it might affect the running, but it really shouldn't. It could. This here could be a little less, so your piston rod could be a little longer. I wouldn't change the stroke. I would just change the piston rod length so that I have lots of room down at the other end. I can make this piston rod a little bit longer, and then it would not come so close here. So that would be the only adjustment I would do, is maybe make this piston rod just a tiny bit longer, maybe 20 thousandths or so, and we'd be just fine. But anyway, this is a running engine. Now, if you go up here to joint, you want to see it run. This is our cylinder joint right here. We should rename that. There. That's the crankshaft to base joint. If you right click on that, say animate model. Oh no, I'm sorry, that's the wrong one. That's the crank pin. Pin to piston. I'm sorry, that was the wrong one. The Revolute joint here, this is the crank shaft to the base. That's the one you want to use. Use that one, animate model, and the engine will sit here and run. And looks pretty cool. You don't even use any air up or any steam or anything. So you can make all sorts of models of all sorts of things, and manipulating and working with joints. You can make them do a lot of things. We didn't cover, of course, all the joints doing this model, but there's more stuff to joints. You can do many videos on joints. But you play with them and you'll be able to figure a lot of it out. Well, thank you guys, and thanks for watching the series. I know it was long, but it's a lot of stuff to cover. And I hope you have learned how to draw some of the basics or model some of your basic things or basic parts in your shop. I mean, that's the goal of this, was to teach you using Fusion by having a project and having it come to fruition. I am going to continue on with this, and we'll make some paper drawings. We'll go through. I'm not going to make all the parts. I'm just going to do maybe one video and get you started in making paper drawings. what you can do. We pretty much cover everything you need to know to at least get going on making paper drawings. One question I did have asked was about exploded views, and I'll probably do one video on exploded views by itself. It's rather complicated to do exploded views and actually make a paper drawing of an exploded view. So I'll make a separate video on that. But thank you guys. Thanks for watching, and enjoy your Fusion days. These are great for the winter time when you have time to sit and do this, or in the evenings. So thank you again, you guys, and thanks for watching, and enjoy your Fusion engine.